Hello, and welcome to an hour of SQL Server Big Data Clusters demos. My name is Pusateri, and I'll be your presenter for this session. Thank you so much for attending, and I'd also like to thank Data Platform Virtual Summit 2021 for having me as a speaker today. If you are curious about what SQL Server Big Data Clusters are and would like a brief introduction into what they are and how they work, and then the remainder of the session to be full of demonstrations about them, then you are in luck. This is probably a session you will enjoy. I'll point out this is one of the sessions in the track where we are allowed only one slide and everything else has to be demonstration related, so that's what I'm going to do, though I must confess to you that I actually have 5 total slides, including the one title slide we're looking at right now, but there's only one with actual content in it. The rest are conference and administrative related slides, so I think that works. So moving right along, just to briefly introduce myself, my name is Bob Pusateri. I am a Microsoft Certified Master of SQL Server and a Microsoft Data Platform MVP. I'm very active in the SQL Server and Data Platform communities in Chicago. I'm a friend of Redgate. I help organize the SQL Saturday events that take place in Chicago. And I am my areas of specialties, I should say, are very large databases, performance tuning, big data, and cloud architecture. If you have any questions during the session, please feel free to type them out in the chat room. This is a recorded session, but I will be answering questions live during and after the session. If you happen to be watching this session later and have a question, please feel free to reach out. You can see my contact information up there on the screen right now. The best ways to reach me are either via Twitter or email, and those are both there. So even if you're watching this later and you have a question, please feel free to let me know, and I'll do my absolute best to get you an answer. So what is a SQL Server Big Data Cluster? And this is my actual one official slide of content here. I thought it would be most helpful to kind of show and go through the architecture of a SQL Server Big Data Cluster for those who are not familiar with it or as familiar with it, or even those who are familiar and maybe need a little bit of a refresher. I have this architectural layout of a SQL Server Big Data Cluster up on the screen, and let's talk about it. Probably the biggest thing you need to know about a SQL Server Big Data Cluster is it runs in Kubernetes. And if you're not familiar with Kubernetes, that could be a topic on its own, and likely is elsewhere in the conference here. But Kubernetes is a orchestration framework for containerized applications. So you can run SQL Server in a container. That feature has been around for several years now. SQL Server Big Data Clusters take that one step further and run SQL Server and the other services of a big data cluster in containers in Kubernetes. And what Kubernetes allows you to do is have pods of multiple workers, and it can maintain certain levels of them depending on how you have it configured. This is management that handles effectively the virtualized processes of the containers itself. Like I said, that's not really on topic for today, but if you're understanding architecturally what a big data cluster is, you absolutely need to talk about that. So I'm going to get out my laser pointer here on the slide deck, and we're just going to go through this slide and talk about what we have here and what it means. So at the very bottom, you'll see the servers, the actual nodes. These can be physical or virtual nodes. These days, you're probably more likely to find virtual nodes than physical, but it officially can be either. And Kubernetes is running on top of and across these nodes so that its services can be provided across any of them. Within Kubernetes, we have kubectl, or kubectl as some call it. This is a utility for managing Kubernetes, so that's an important part. And then within Kubernetes itself, we have the big data cluster proper, which is the represented by the bluish box here. Within the big data cluster, we have a utility called AZData, which is used to actually manage and create the big data cluster itself. We have Azure Data Studio, which plays a decent role in a big data cluster because Azure Data Studio has the plugins and tooling to manage a big data cluster for you, so that's rather important. Pretty much every part of the big data cluster exposes some sort of web service. So we have web services here, and then within this orange box, we have the actual major components of the big data cluster. So we'll start by actually talking about the master instance here. And the master instance is effectively a regular SQL Server instance within a big data cluster. Now, it's a regular SQL Server instance, again, running on Linux on Kubernetes, but is a regular SQL Server instance nonetheless. It's also the main endpoint for when you want to connect to a SQL Server big data cluster. So shortly, I will be demonstrating how to connect to one, and what I will connect to, and I will point this out at that time, is the master instance. And you can connect to this with Azure Data Studio. You can connect to it with SQL Server Management Studio, just like any other SQL Server instance. If you were to want to bring data into the big data cluster, perhaps by restoring a SQL Server database backup from another server somewhere, you would actually restore that backup into the master instance. So it's your main endpoint for dealing with most of the big data cluster. It handles all the communication with the other aspects of the big data cluster. It also handles all the metadata used to manage and maintain the big data cluster. So the master instance plays an important role, and that's why we talk about it first. Another major part of the master instance is external tables in Polybase. Now, Polybase is a feature that has been around in SQL Server for several years now, starting in SQL Server 2014 or 2016, I believe. So Polybase is not part of a big data cluster specifically, but it does play a major role in the big data cluster because Polybase allows you to expose what are called external tables. And as is the case in a big data cluster, most of the data in a big data cluster will not be physically residing on that master instance. So we will link that data to it using external tables with Polybase. So these, if you've never used Polybase before, you can take files that are somewhere else, not on the SQL Server, and they're like a CSV file or a Parquet file or something like that. So even sitting in Hadoop, which is the case here with the big data cluster, you can effectively map these files as a table. Now, it's called an external table because there are some catches. Most notably, external tables are read-only. So you can bring in this data as an external table, and you can join it to any other table, whether it's an external table or a table that is physically located on that SQL Server. And it's a nice, seamless way to do that. But you cannot insert, update, or delete data in an external table. You cannot create indexes on data that's in an external table. You can't do pretty much anything because they're read-only, but you can read from them. You can create and select statistics on an external table, but that's like the biggest exception. Otherwise, external tables are read-only. And if you try to do something that is not a read-only function, you'll get an error saying external tables are read-only. So external tables play a major role in a big data cluster, and then they'll be frequently used on the master instance, and we will touch on some of that when we get to the demos momentarily. Next here we have the SQL data pool. This is a really neat feature of a big data cluster. This is a pool or a set of SQL Server instances that provide storage and compute services to the big data cluster, and this is managed via the master instance. So if you create your SQL Server big data cluster with a SQL data pool, and let's say you have 4 instances in that SQL data pool, any data you place on this SQL data pool will have its records distributed evenly across all the members of the data pool. So if you have 4 servers in the pool and you have 40 billion rows that you load into your SQL data pool, you'll get about 10 billion rows on each of those 4 servers in that pool. Right, so it'll distribute them, simply and evenly. Now, the cool part about it is if you need to execute a query on the data in the data pool, You just execute a query to the data pool, and behind the scenes, the data pool will go ahead and query each of its members separately for whatever data you're looking for, and then combine their results together into one simple result set and return it to you. So if you have like frequently run large, expensive queries, and you're using a SQL Server big data cluster, that might be a good candidate to have that data in the SQL data pool so that you can, cover large amounts of data very, very quickly for querying purposes. So that's the SQL data pool. Next, we're going to talk about the storage pool here, and the storage pool is a HDFS or a Hadoop distributed file system cluster that lives within the big data cluster. So this will provide persistent storage for your unstructured or your semi-structured data, your big data. If you have CSV files, if you have Parquet files, things like that, you can put that all in this storage pool, and it will be sitting on HDFS within the big data cluster. And then you can access the data in the storage pool in several ways. First of all, you could expose it and mount it as an external table in the master instance and query it that way via Polybase, like I was just talking about. That's definitely an option. But the other cool thing you can do is you can query that data through Apache Spark. So you can issue Spark queries against the contents of your storage pool and get everything that way. You can access the data multiple different ways when it sits in the storage pool. Next up, we have the compute pool, and that provides scale-out computational resources to your big data cluster. So if you have distributed query workloads you're working on, your master instance can actually offload those workloads into the compute pool. This is essentially a set of, again, SQL Server instances, but they're stateless instances. So this would provide, some functionality, like if you're familiar with Polybase scale-out groups, which were, I believe, they started being available in SQL Server 2016. The compute pool can handle that. Queries can absolutely function without the compute pool as well, but certain types of queries may get offloaded to it if it's available and can have better performance as a result. And then finally, we have the application pool, where you can actually bring applications into the big data cluster and have them execute there as well. So this is just a very, very brief architectural review of a SQL Server big data cluster. This is definitely a topic you could spend an entire session on alone, and I've seen others do that. But again, to get to demos, I wanted to give a brief highlight of how this works, and thought my one slide would be an excellent way to do that. So if you have any questions about this, feel free to type in the chat or reach out to me. And with that, we're actually going to go ahead and get to some demonstrations here. So I'm going to open up Azure Data Studio. And as you can see, I have nothing here. So the first thing we need to do is actually go ahead and create a SQL Server big data cluster. Now, let's talk about it here. So the easiest way to create a big data cluster is actually through Azure Data Studio. If you click on your servers up here in the upper left, and then click on the three dots, the ellipses here, and go to New Deployment, you will see there's a bunch of things you can actually deploy through Azure Data Studio. They've added all these features in here, which is awesome, but one of them is, in fact, SQL Server Big Data Cluster. And if you click on that and hit Select, it will actually start to walk you through a wizard, effectively, to go ahead and get that big data cluster built. And it's actually warning me up at the top at a big error that apparently my version of AZ Data, which I have installed locally here, does not meet the minimum version requirement anymore, which is funny because I actually just deployed yesterday with that version of AZ Data and it works, but clearly they're trying to get you to upgrade. So I guess this is a good thing to point out. AZ Data, which is one of the utilities you install locally, is necessary for deploying big data clusters in the cloud, which I realize might not make sense. You're probably thinking, well, if I want to create something like, Azure SQL Database, I'd go to Azure Portal and say, hey, please provision me a SQL database, and it would do its thing and give it back to me. Your local machine doesn't really have anything to do with that there. But in the case of a SQL Server Big Data Cluster, your local machine is actually doing some of the work and telling the Azure resources how to deploy it. So that's what AZ Data is necessary for. So that's why you actually need this tool installed on your local machine to do it. There's a couple other things you need installed locally to do that as well. You need kubectl, and you need the Azure CLI installed. There is also, and I'm going to, well, here, I'll talk about this first and we'll get the other thing. So you work through your wizard here, and when you get done, Azure Data Studio will actually go ahead and return to you a notebook that has all the steps necessary to create the big data cluster for you. So I'm going to drag this notebook in here and just open it up and show you. So this is literally the notebook that Azure Data Studio will produce. I have since customized mine a little bit. I've filled in some extra blanks and changed a couple things, which is why I have it saved off separately. But it is a notebook that will go through and create the big data cluster for you and return to you the connection information. So if you wanted to build a big data cluster right now, you would just hit run all. It would go ahead and prompt you for a master password for the big data cluster, and it would prompt you to authenticate your Azure account so that it knows where it's deploying it in Azure. But besides that, it would go off and do its thing. This is not a fast process to deploy a big data cluster, which is why I'm not actually deploying one live for you right now. It took about 25 minutes to deploy the cluster that I'm going to use for demonstration purposes here. So obviously we didn't want to spend half the session looking at this thing, spinning around and creating the cluster. So that's why I did it ahead of time. But that is how you create a big data cluster, or at least what I think is the easiest way is using the wizard here in Azure Data Studio. And then if you create them frequently, as I do, save off the notebook, and then you'll have a notebook that will go ahead and do it for you. Now, the other thing I was going to point out is that if you are using big data clusters in Azure Data Studio, there is a plugin you will want to have as well. This is the Data Virtualization plugin. This is a plugin from Microsoft. This will provide some helpful wizards and tools when you are dealing with virtualized data, such as external tables like we talked about. So you want to have this installed in Azure Data Studio as well. So once you've deployed your SQL Server Big Data Cluster, and like I said, I've already deployed one, so I'm going to go ahead and connect to it now and show you what that looks like here. Our first demo here. So I am now connected to a Big Data Cluster in Azure Data Studio. See it represents itself over here as a server and looks mostly like any other SQL Server instance we might connect to. I'm going to go and click on databases here, and you will see that we have system databases, just like any other SQL Server instance, master model, MSDB, and TempDB. But then we have these three other databases here. And they are not system databases officially. They are user databases, which is why they show up as user databases. But these are the administrative databases for the big data cluster. So they are called DW Diagnostics, DW Configuration, and DWQ. My rule of thumb is do not touch these databases. Do not mess with them. Do not drop them. Just let them be. This is the big data cluster's way of maintaining its metadata and its records and configuration. So we're not going to mess with those, but they are there. So be aware of that. The next big thing I want to show you here under BDC is we do have a folder called HDFS, and this is in fact a folder that will get you into the Hadoop distributed file system that is part of the big data cluster. So if you are looking to work with data that is in HDFS in your big data cluster, as we will be doing in the demonstrations here momentarily, you can actually access that all through a folder in the server window, which is pretty nice. Now, to briefly talk about the other aspects of a big data cluster that are available here in Azure Data Studio real quick, you'll see there is a tab here called SQL Server Big Data Cluster. If we click on this tab, we will get a list of all the service endpoints that our big data cluster is using. As I mentioned, there's a lot of things that are exposed through web services. There's a lot of different pieces and ways to connect to them. So this is like a very nice one-stop shop list of all those endpoints. So we have the top one here is the master instance, or the front end, which is what I'm connected to now. As I said, that's your main connection point. But then there's a cluster management service. There's different dashboards. You can see all the logs that are being generated by the different aspects of the cluster. There's a HDFS endpoint, application proxy endpoint, etc. So there's a whole bunch of endpoints here, and it just lists them out for you very nicely. The other thing is if you go up here and click on SQL Server 2019 Guide, this will actually open a whole bunch of notebooks for management of the big data cluster. So if you are trying to troubleshoot or just trying to learn and want to see what you can do, how it's done, Microsoft actually provides all these notebooks with issues. Want to learn how to deal with logs. Here's all the log notebooks. Here's diagnosis notebooks, etc. So they went ahead and compiled all this documentation ahead of time, and it's just included with Azure Data Studio for the big data cluster. And lastly, the one thing I'll show you here is the cluster dashboard button. This will bring you to a dashboard of the whole cluster. Once again, it has all those service endpoints for you, but it also shows you all the different services of the big data cluster that are running. So we have the SQL Server service, HDFS service, Spark, etc. And you can deep dive into these and see exactly, how are they running. Okay, this is HDFS service. That's the name node. This is the storage. Here's the Spark head node. SQL Server. We have the master. We have the compute. We have the data. We have the storage, etc. So you can see all the different components of the big data cluster if you deep down into that dashboard functionality that, again, is just provided in Azure Data Studio, which is pretty awesome, which is why I like to work so much in Azure Data Studio in general, but especially when I'm using a SQL Server big data cluster. So with that in mind, I think we've covered everything environment about it. So with that in mind, let's get started and actually work on a demo. All right, let's get started with this demo here. I've gone ahead and just adjusted the size of the text in Azure Data Studio a little bit to make it larger, so hopefully it's easier for people to read. First thing I'm going to do is go ahead and copy this first demo notebook into Azure Data Studio. And yes, I will absolutely make the demo materials and the slide deck, if you'd like to see all 5 of those pretty slides again, available for download wherever files for the conference are downloadable from. So those will all be there. So here is our first notebook, but actually the first thing we're going to do before we work through the notebook is we're actually going to load our first piece of demo data here. So I have some sample files I'm working with. They concern airlines and airports and flight delays. These are CSV files. I got them from Kaggle.com, and if you're not familiar with Kaggle.com, it is a website for people who are interested in data science. So there's lots of tutorials, but also lots of good sample data you can download. So the sample data itself, I cannot include in the downloadable conference materials because of the distribution agreements with Kaggle.com, but I will give you a link so that you can go to Kaggle.com and get them yourself if you would like to. So I'm going to upload these files into HDFS so we can actually work with them. So here I'm clicking on HDFS, and we have some system-created folders, but we're actually just going to create a couple folders of our own here. So we can do this right in Azure Data Studio. Right-click, say New Directory, gives you a box at the top there in the middle, which might not be where you're looking for it, but it's there. So I'm going to create a folder called Airlines. And so there we go. We have a folder called Airlines. I'm going to create another folder called CSV within Airlines so that we know we're dealing with CSV files to do with airlines. And then in here, I am actually going to upload the file itself, which is called airlines.csv. So I'm going to hit Upload Files. It's going to, I need to, where do I want to upload from? I want to upload from here. There we go. This is a relatively small file, so it uploads quite quickly. So now we have this sample file, airlines.csv, sitting in our HDFS store in the SQL Server Big Data Cluster. So just to show you what you can do with this very, very quickly, if you right-click on the file, you get a couple options here. First one I will show you is called Preview. And Preview will just go ahead and literally read the text file for you, right? This is a fairly small text file, so it's not billions of rows or anything, but it will just straight up read that text file out. So we can see this is a CSV file. Has a couple columns here: airline ID, name, alias, the codes for the airline, the call sign, the country it's from, and whether it's an active airline or not. I do not want to save my changes. I just wanted to show it to you in preview. The other cool thing you can do is you can click and say virtualize data from CSV files. And this is a wizard, and this is part of that data virtualization plugin I told you earlier that you should download and put in Azure Data Studio. This is going to produce a wizard that will walk you through this step by step. Now, I am not going to use this because I'm going to do it on my own in the notebook here, but if you wanted to create a virtual table, you could absolutely do that. And if you saw the error I clicked away from, that was just telling me there is no database currently to create the external table in. So I have to create a database, which is actually the very first step in my notebook here. So I'm going to go ahead and connect my notebook to my big data cluster. And I'm going to go and create a database, and I'm going to call my database airlines data, and I'm also going to create a schema within that database called CSV because we have some CSV data we're going to be putting in there very shortly. So there we go, I did that. If I were to refresh this now, you will see there is a database called airlines data, right? And again, this is on the master instance. This is a regular SQL Server database like you would use in SQL Server or Azure SQL DB or whatnot. So it is no different at this point. It has all the same features and functionality. So now that I've created this database, I'm going to go ahead and create an external table to map to that airlines.csv file. And if you've ever worked with external tables in Polybase before, this will probably look no different to you. But if you haven't, I'm gonna talk through it anyway for benefit. And before I forget, I am going to check real quick and make sure my Zoom It works. No, it does not. So give me 10 seconds here to just go ahead and start Zoom It. Because for some reason on my computer, Zoom It does not start when Windows starts anymore, and I don't know why. So there we go. I think I can zoom in now. Good, there we go. All right, so I can zoom in and show you things as necessary. All right, thank you for your patience. So first thing I'm going to do is just simply create an external data source. So create external data source, SQL storage pool. So this is this is where the file is located. It's located in the storage pool, right? We just put it into HDFS in the storage pool. So you'll see we have a special location for that, SQL HDFS : controller service / default. That is just how to get to the file system. So we need a data source to do this. So I'm going to go ahead and create that real quickly. Next, we need to define the file format for the file, which is a CSV file. I'll zoom in on this for you just to make sure it's easy to read. It is a CSV file format. It is a format type of delimited text. The field terminator is a comma because it's a CSV file. It does have delimited strings with quotes, with double quotes, so that's set as a string delimiter, and the first row was the name of the field, so the first data row is row number 2. So we have now defined where to find the file and the format of the file, so now we go ahead and actually create the external table. And again, I'll zoom in and talk through this for those who may not be familiar with this process. Create external table looks a lot like a regular create table statement in SQL, except it's create external table. You do have to define the columns and the data types, just like you would with any other SQL Server table. But then you'll notice at the bottom here with location. So we give it the location of the file that makes up this table, which is what I created earlier, the airlines CSV, airlines.csv. The data source is the storage pool that we defined, and the format is the CSV file format that we defined. So if we're telling SQL Server, hey, create an external table based on this file with the properties that I've already created. And you'll notice it happens very, very quickly because this is a metadata mapping behind the scenes, right? This is not copying that data into a table somewhere. This is just creating, effectively some sort of pointer that says, hey, when someone references this external table, which will show up under tables now, right? Zoom in on that for you. Under tables, we now have csv.airlines. It's pointing out that it is an external table, but a table nonetheless. And it is there. So we can now go ahead and query that table, just like we can query any other database. So I'm going to issue a query here, just select top 100 star from csv.airlines. And it's going to think for a moment, and then it's going to barf, right? It's going to give us an error, which this is an error I'm expecting, so don't feel like it blew up on my face and I didn't know it was going to happen. I actually knew it this time. So if you've ever worked with polybase or external tables, you've probably run into an error like this at some point. And basically it's saying it's not able to read this file because it does not match what it expected. Essentially, we had to define the file up here, and if what's in the file does not actually match the data types and the lengths that we defined in it, then the external table will generate errors at runtime, because remember, it's not verifying anything when you actually create the external table. It's only doing it when you try to read from it. So never fear, we do have some ways to address this. So I'm actually going to use the next feature of the big data cluster, Spark, to work through that. So I'm going to open up another notebook here real quick. This is a second file. Now this is a Spark notebook. So instead of working in SQL like I just was, I'm now working in Spark, if you are familiar with that at all. So we're going to go ahead and connect this as well. And this is using the PySpark kernel. So Spark has the advantage here, and I typically use it for this a lot. It's a bit more forgiving when it comes to things like data types. So what we're going to do is we're going to use Spark and try to figure out what the issue is in our file. So the first cell I'm going to run here is just going to read in the file and show me the first 10 rows. So we're defining what's called a data frame, which I'm just calling df here, and saying read from this file effectively. Yes, it has a header. This is the file in this location. It's a CSV file, and then show me the first 10 rows. So I'm going to click on this, and this is actually going to take a few moments to start, just because this is the first time this has run since Azure Data Studio has been restarted, so it has to start the Spark application. So this is going to spin around for a few moments and initialize itself, and then it will actually go ahead and return the first 10 rows of that file. So hang on here. There we go. Great timing, huh? All right, so this is literally just printing out the first 10 rows that it read from that file, which is great. So first thing I'm going to do here in Spark is just run df.print schema to show you what that looks like. And these are just showing you the columns and the data types as Spark sees it. You'll notice the airline ID is an integer, and everything else it says is a string. So there's no like varchar or varchar with a length on it, or car, char, or anything like that. Everything is either, is generally a string in Spark, which is cool. So we have that information. Next, I'm going to use a package called pandas, which is another way to read and process data in Spark. I'm going to create what's called a pandas data frame so that I can do use some pandas functionality on it. So I'm going to run this one now, and what this is going to do is give me, essentially, I'll zoom in on it for you here, this query that I just ran is saying, what is the largest value lengthwise of each column in this entire file? So we have airline ID of 5, name is 81, etc. The one that I created the error in actually is country. So you will notice country has a maximum length of 37 characters. And if we go back to SQL Server here, when I define this external table, you'll notice I defined country as only having a length of 10. So that's what's actually causing the error in this case, is wrong column length. And some of the wizards will actually go ahead and try to determine the column lengths for you while you're creating the external table if you're using Wizard to do that, but usually the Wizard only read the first couple thousand rows. So if you have millions and millions of rows, you could still very well have this problem, which is why I find it very, very helpful to have Spark do this for you. So with that in mind, we are going to actually drop the external table that I had created. I'm going to adjust the country length, knowing that the maximum length is 37. I'm now going to create it as 40 instead of 10, so everything should be able to fit there. And now when I select my top 100 rows from CSV Airlines, voila, it works. So now we can see all the rows and values in this table, at least the top 100s. So again, we have an airline ID, we have the name of the airline, we have a IATA code, an ICAO code, their call sign, what country they're from, and whether or not they are still an active airline as of whenever this data was created. So those are the columns we have to work with. As I've pointed out earlier, this is again an external table. So if I were to try to do something like create an index on it, SQL Server will say, nope, can't do that. Indexes are not supported with external tables. Very much the same thing if I were to try to update data. DML operations are not supported on external tables either. But what we can do is we can do an awful lot of selecting, which is what we'll be focusing on when we work with external tables in the future. So here I will just run a regular SQL query, select star from csv.airlines, looking for the active airlines in Belgium, and get those results just fine. And remember, behind the scenes, what this is doing is this is actually not reading from a table at all. It's going ahead and reading directly from a CSV file to produce these results. So that's our first demo, just looking at airline data, and we'll be back just a second with the rest of our demos. All right, for our next set of demonstrations, we're going to begin by loading another set of data. And I know before I showed you how to do this via the Azure Data Studio GUI here for HDFS, but for this second demonstration, I thought I would do it via script instead. As I mentioned before, there's a lot of endpoints you can make use of in a SQL Server Big Data cluster, one of which is for HDFS. So what I have here is a script, and again, this will be included in the download if you'd like, that will use the HDFS endpoint instead. So up here, it will actually go ahead and connect to the service, and then below it will go ahead and copy the file called flightdelays.csv from a local folder of mine into the folder itself. So let's give this a whirl here. Just going to click Run All. Let it do its thing. Shouldn't take too terribly long. And there we go. All right, so now if I refresh my HDFS, you'll see we have a second folder here now called flightdelays.csv with another CSV file inside called flightdelays.csv. So this was uploaded and all these folders were created just by using this Python script instead of doing it manually. So easy way to save a little time. I'm going to go ahead and exit out of that and load our next demo script where we deal with the flight delays data. So much like before, we're going to work with the airlines data database that we've already created, that we have our csv.airlines external table in. So we're going to use that. I need to connect to the instance again. I just opened this file. There we go. So we're going to use our airlines data database. I'm going to create a flight delays external table, which does not have any errors in it this time. So it's just pointing at that file, and we should be able to create it very quickly and query from it very quickly as well, and shouldn't have any issues. So just to talk briefly about the data contained in this particular file, this is flight delay information. So we have some date information here on the date of the flight, the departure time, the scheduled departure time, the arrival and scheduled arrival time, the airline, the flight number, the tail number of the aircraft, the elapsed time, the scheduled elapsed time, so you can calculate the delay, whether or not the flight was canceled, where it was to and from. So we have a whole bunch of this data. I'm just downloading the top, or just selected the top 100 roles to do that. So now what we're going to do is we're going to take these CSV files and we're actually going to make a copy of them in a different format called Parquet. And if you're not familiar with Parquet, it is a compressed binary format. It's actually compressed in a kind of like a column store manner to talk in SQL Server speak. And it is very popular with data science because this is a compressed format, like I said, that's compressed in a column store method, so you can do things like eliminate columns and get some optimizations just purely out of the file format. Probably the biggest downside of Parquet is it is not a text format, it's a binary format, so you can always open a CSV file in a text editor and see what the data looks like. Parquet file, you cannot do that. But to convert it to Parquet, we're going to use Spark. So I have a notebook for this as well here. I'm going to go ahead and actually soon as this lets me, I'm going to attach it and get it going because it's going to have to start the kernel again like before, and that's going to take a few moments. So this first one is just going to start the Spark application, and like before when I showed you the airlines data, it's just going to return the top 10 rows. But while it's doing that, I'm going to talk about the next line here in the notebook, which actually will write this data out to Parquet. So once again, we're defining a data frame as variable df is what I'm calling it here, which contains the file. But then what we're doing down here is saying df.write.parquet. So we are writing the data frame contents out to a Parquet file. And what I will also point out here is you'll notice I don't have a file name specified. This is just a directory path, right? Flight delays / Parquet. That's because this is going to execute in parallel across all the workers. Now, in this case, there's only 2 workers in our Spark cluster. But what it's going to do is it's going to, and this is very common in Parquet and data science, is you have all the data across multiple files in a folder, and then you point your whatever processing engine you're using to that folder, and it will just go ahead and scan all the files in that folder. So this is running. Did it finish already? Did I start it? Hang on. There we go. Okay, right. So it already exists. So it did it very, very quickly. What you'll see here we have now flight delays, and we have Parquet. And you'll notice under here, under the Parquet folder, we in fact have 3 folders. We have 3 files rather. We have 2 files which are named with goods, and the third one, which is success, which just means that it successfully finished writing the contents out. So there we go. We have all this data in now a Parquet format that we can work with. So now that we've done that, we're going to go here and create some external tables to read the Parquet data as well. To do this, we're going to actually create a new schema. Remember, we had a schema called CSV because our tables are csv.airlines. Well, we're also going to create, and actually there's a second table called csv.flightdelays, showing the CSV version of the flight delay data. Well, now we're going to have Parquet.flightdelays, so we can look at, compare the two. So we're going to create a schema called Parquet. We're going to create a file format called Parquet as well, representing the Parquet format that the files are in. And we're going to create another external table. This time, like I just mentioned, instead of pointing at a file, the location is actually a directory. It's just the flight delays / Parquet directory. But the columns are defined in the table, and then we have the directory that is the source. So there we go. If I refresh tables, you'll see we now have a third table called Parquet.flightdelays, which is the Parquet version of an external table. And if I select the top 100 rows from Parquet.flightdelays, we'll get the top 100 records back. So now we have the same flight delay data both in a CSV format and in a Parquet format, both represented through external tables. But we're not done yet. We're going to do another transformation here, and we're also going to copy this data into the SQL data pool. And if you remember from earlier, the SQL data pool was a pool of SQL Server instances where when you copy data into it, the data all gets distributed evenly across however many instances are in that pool. In my case right here, this pool contains 2 instances. What we're going to do is we are going to create a external data source called SQL Data Pool. And before, if you remember, when we did this for Hadoop, it was SQL HDFS. Well, now the location is SQL Data Pool, and it just says, hey, this external data will be in the SQL Data Pool. So there we go. I've created the data source. I'm going to create another schema called Data Pool, and we're going to create a final external table here called datapool.flightdelays. And once again, like all the other external tables, we'll define our columns and our data types, and that's fine, but I'd like to call particular attention to the bottom here. So we're saying with data source equals the SQL data pool, and with the distribution equals round robin, which is, as I was describing, it will go ahead and distribute the data between the members of the pool in a round robin fashion. So let's create that external table. And now that we've created that external table, we need to actually load the data into the data pool, right? But before, with external tables, it was just a pointer to somewhere, right? A file somewhere, which is the same here. It's a pointer to the data pool, but now we need to copy the data into the data pool. So to do that, we're just going to use a regular insert into, where we're inserting into data pool.flight delays, and we're going to select star from csv.flight delays. And this will actually, take a few moments because it is going to actually copy all the rows from CSV into the SQL data pool. All right, there we go. We have copied a total of 19.36 million rows into the data pool from the CSV file. So now if I were to select count star from the data pool, I should get that same number back, which I do, 19.36 million. Okay, so now that I've done that and I was able to count that data, let's take a look at how many rows are on each node of that pool. We can actually do that with a query here, and I'm going to zoom in just to talk through it real quick. So this is a query, execute, use airlines data, select count star from data pool.flight delays, but then you'll notice we have at the back here, we have at data source SQL data pool. So rather than executing this query on each node of the pool, combining the results and returning a result set, this is going to keep the results set separate for each node of the data pool. So you'll notice we get two results back because it was two nodes, and the numbers are very, very similar. Only 30 rows of difference between the two, so it's not quite row for row round robin. I'm sure it's done in some level of a batch, but a pretty small batch when we have two, and there's only 30 rows of difference between the two of them. So that's just showing you the data has been equally, or very roughly equally, distributed between the two nodes of the SQL data pool in my case. And again, if you had more members of the data pool, then you would have more distribution between all of them. Now that we've set all this up, let's do a very, very quick performance comparison. So what I'm going to do here is just count the records. And we're going to count the records in a CSV file, in a Parquet file, and then in the data pool as well. And this may not sound impressive, but think about what's going on. Because remember, these are external tables. So it's having to go and read this CSV file, read in every row, and count it. Right? When I say select count star from csv.flight delays, this took a total of 7.5 seconds to execute. If I do this against a Parquet file now, which remember contains all the same data, just in a compressed format, well, that took 0.4 seconds instead of 7.5 seconds. So clearly the Parquet file, which is compressed, and I'm sure there's other metadata available to help speed up aggregate functions like counting, makes that very, very quick. Finally, we can take, and we're going to count from the SQL data pool, which will count the results, and that takes even less time. That takes 0.2 seconds. So half the time it took to read from the Parquet file, I actually did it from the SQL data pool. So as you can see, we get some serious performance benefits when we have our data in a Parquet format as opposed to a CSV format. And if we're doing, frequently run, like I said, analytics type queries where we want something very fast and very available all the time, put it in the SQL data pool, you can get even better results than Parquet depending on what you're doing. And finally, here is one last little demo I wanted to point out or show you, because one thing I haven't shown you yet is, once again, the ability to join, right? So we can actually join between these external tables. So I have a query here where I'm selecting the top 20 rows, and I'm joining the Parquet version of flight delays to the CSV version of airlines, right? So these are two different file formats. External tables, but because they're external tables, I can still join them together seamlessly, right? So here we go. Here's this result set where it has joined this back, and you wouldn't know if this was locally in a database or anywhere else because it's quite seamless. So that is this demo. We have just one more here I want to show very, very quickly. The final thing I want to show you here quickly is just another capability of the HDFS in the big data cluster, and that is you can actually mount other file systems into it. So if you have data that is in a different Hadoop file system somewhere and you would like to mount that into this one without actually having to go and physically copy the data, There is a solution for that in a big data cluster, so we can actually right-click on HDFS, and you'll see it says down here one of the options is Mount HDFS. So you have to fill in some information here, so you need to know, of course, where are we mounting it to. So I have some data that is sitting in an Azure Data Lake. It is City of Chicago parking ticket data. I've done some work and some blog posts on that in the past. But just to show you how that works, we're going to mount this. We're going to mount it in /MNT/parking tickets. This is the path to go ahead and get it. And I have a credential here to access this. And if I hit OK, it should be able to mount this from an existing Azure Data Lake storage into HDFS. So let's see if this works. Yep, got a green check mark. So if I hit refresh here, we have MNT, parking tickets. They are CSV files from 2003. And here we go. We have all this parking ticket data that I was able to just pull in and mount, just like any other Linux type file system mount from a different HDFS system. In this case, actually running in Azure Data Lake Generation 2. So there's lots of flexibility here. I realize these were some brief demos today, but I really hope they give you a better idea of the type of things you can do with the SQL Server Big Data Cluster. So just to briefly close up here, let's go back. We covered what is a big data cluster, of course. So once again, thank you for attending. I really hope you enjoyed this session. Thank you to Microsoft for supporting this event and the Data Platform Geeks and SQL Server Geeks community initiatives and all the other community initiatives that Microsoft so graciously helps support around the world. Again, thank you. Please post a selfie with a hashtag to win prizes. Visit the exhibitors and the sponsors because they're who help make events like this possible. And I would very much appreciate any feedback you would like to give. So with all that out of the way, let's answer some questions. If you have any questions that I haven't yet been able to address in the chat, now would be a great time. And once again, thank you for attending. I really appreciate you coming today and hope you enjoyed. Thank you and have a good rest of the conference.